Ever wondered what actually happens when you type a website into your browser and hit enter? It feels like magic, right? 1 second you're staring at a blank bar. The next you're scrolling through cat videos or buying shoes you probably don't need. But it's not magic, it's the internet. And today we're going to pull back the curtain and see exactly how this incredible system works, using some simple illustrations. So, let's start with the basics. What is the internet? At its core, the internet is just a massive, global network of connected computers. Think of it like a giant spider web, but instead of spiders, you have computers, phones, servers, and all sorts of other devices. And instead of silk threads, you have physical cables crisscrossing the globe, running under oceans and over land. Yes, most of the internet is connected by actual, physical wires. Now, when you want to visit a website, say, our amazing YouTube channel, you're not directly connecting to YouTube. Instead, you're sending a request. Your computer is the client, and the computer holding the website's data is the server. So, you're a client asking a server for some information. But how does your computer know where to find the YouTube server among the billions of devices online? Every device connected to the internet has a unique address, kind of like a phone number. This is called an IP address, which stands for Internet Protocol Address. It's a string of numbers, like 17.to.17.16.14. Now, you're probably thinking, I don't type a bunch of numbers to get to YouTube, I type youtube.com, and you're right. That would be a nightmare to remember all those numbers. This is where something called the DNS, or Domain Name System, comes in. Think of the DNS as the internet's giant address book. When you type youtube.com into your browser, your computer first sends a query to a DNS server. It asks, hey, what's the IP address for youtube.com? The DNS server looks it up in its massive directory and replies with the correct IP address. It's like asking your phone's contact list, what's mom's number? And it gives you the digits. This whole process happens in a fraction of a second. Okay, so now your computer has the IP address for the YouTube server. It knows where to send the request, but how does the request get there? This is where packets come into play. Your request isn't sent as one big chunk of data. Instead, it's broken down into tiny pieces called packets. Imagine you're sending a huge encyclopedia to a friend across the country. Instead of trying to mail the whole heavy book in one box, you tear out each page, put each page in a separate envelope, and mail them all individually. That's what your computer does. Each packet contains a small part of your request, plus information about where it's going, the destination IP address, and where it came from, your IP address. It also includes information on how to reassemble the message at the other end. These packets are then sent out onto the internet. They travel through a series of routers. A router is like a traffic cop for the internet. Its job is to look at a packet's destination, address, and decide the best and fastest path to send it along. Your request might hop through a dozen or more routers on its way to the server, traveling through those physical cables we talked about earlier. These could be fiber-optic cables laid under the ocean or standard copper wires in your neighborhood. So your packets travel from your computer to your home router out to your internet service provider or your ISP, the company you pay for internet access, and then through a complex network of routers and switches across the world, all heading towards that one specific IP address. It's an incredibly efficient system designed to find the quickest route. If one path is blocked or congested, routers will automatically redirect the packets to a different path. Finally, the packets arrive at the destination, the YouTube server. The server collects all these tiny packets. It then uses the information inside them to reassemble the original message, just like you would reassemble your encyclopedia by putting the pages back in order. The server now understands your request. Please send me the homepage of YouTube. The server then does the exact same process, but in reverse. It gathers all the data that makes up the YouTube homepage, the HTML code, the images, the videos, the text, and breaks it all down into thousands of packets. Each of these packets is addressed to your computer's IP address. The server then sends these packets back out onto the internet. They travel through that same web of routers, each one directing them towards your home. Your own ISP receives these packets and sends them through the final leg of the journey to your router and then to your computer. As the packets arrive, your computer's web browser starts to reassemble them. It's like receiving all those individual encyclopedia pages in the mail and putting them back into the binder in the right order. As the data comes in, the web page starts to appear on your screen. First the text, then the images load, and finally the videos become ready to play. And all of this your request, the DNS lookup, breaking the request into packets, routing them across the world, the server's response, breaking that response into packets, and routing them all back to you to be reassembled happens in the blink of an eye. Typically, it takes less than a second. It's an astonishing feat of engineering and coordination. Let's quickly recap the entire journey. First, you type a domain name like www.youtube.com. Second, your computer asks a DNS server for the corresponding IP address. Third, your browser sends a request, broken into packets, to that IP address. Fourth, these packets travel across the internet through a network of routers. Fifth, the server receives and reassembles the packets, understands the request, and prepares the data for the website. Sixth, the server breaks the website data into packets and sends them back to your IP address. Finally, your browser receives and reassembles these packets, displaying the complete web page on your screen. And this doesn't just happen for websites. It's the same fundamental process for sending an email, streaming a movie, playing an online game, or having a video call. Everything you do online involves this incredible dance of packets being sent and received between clients and servers. Now, you might be wondering about Wi-Fi. Where does that fit in? Wi-Fi is simply a way to connect to the network without a physical cable between your device and your router. It uses radio waves to send and receive packets for that first and last part of the journey. Once your data gets to the router, it usually hops onto a physical cable to continue its trip across the wider internet. So, Wi-Fi is about local, wireless access, but the global internet backbone is still very much wired. It's truly amazing when you think about it. Billions of devices, all talking to each other, sending trillions of packets every single second, through a physical infrastructure that spans the entire planet. It's a decentralized, resilient system that has completely transformed the way we live, work, and connect with each other. So the next time you're waiting that split second for a page to load, you'll know exactly what's happening behind the scenes. It's not magic, but it is a masterpiece of technology. A global conversation happening at the speed of light. Thanks for joining us on this deep dive into how the internet works. If you found this explanation helpful, give this video a thumbs up and don't forget to subscribe for more simple explanations of complex tech. Let us know in the comments what you'd like us to explain next. See you in the next video.